it's like the formula is x equals something plus or minus the square root b squared minus 4ac all over 2a. It's stuck in my head. Like that
That
thing.
is the quadratic formula. This is what you use if you cannot factor a quadratic. In other words, if I give you the following quadratic, I can factor that. That's x minus 5 times x minus 2. But if I change that to a 9, I can't factor it. I cannot find any factors of 9 that add to 7. So if I have a quadratic that I cannot factor, then the only solution is to use that. Now, in the quadratic that I gave you, x squared minus 7x plus 9, tell me what A, B, and C are.
A is it's been a while. A is x.
It's 1. It's never x. It's the coefficient. Always.
Okay.
What's B?
All right. B is 7, negative 7.
Negative 7. What is C?
Positive 9.
Okay, let's plug that in. So if we're solving this quadratic, what do we get? We get x equals, go ahead.
X equals, what are we?
What is negative B equal to?
Negative B equals to positive 7.
Good.
Okay.
B squared?
B squared is negative 14. No, 7 times 7.
It's negative 7 times negative 7, which is positive 49.
All right.
What's the rest of it? 4
minus 4.
1 times C. And I always recommend you write it exactly like that. Do not do this math in your head. The first step in solving the quadratic formula is to always just substitute. Now what do we got? We got x equals 7 plus or minus, what's the rest of it?
Plus 7 plus or minus 14. Like, do we do everything under the square root?
First of all, you do that, you get 36.
36.
And then you subtract 36 from 49, and you get 13. That are your two answers. And just in case you're wondering what that plus or minus means, it means this. One answer is this, the plus. The other answer over here on the left is the minus. That's what the plus or minus means. So that's one answer to this equation that I gave you. That's the other answer. Written exactly like that. You don't need to convert that to a decimal. These are the most exact answers you can have. And you can represent it in just one answer, like on the lower right, by using a plus and a minus at the same time. Okay, how about you give me some problems and we'll tackle those.
Oh, I have some like missing homework from a while ago that I haven't got to yet.
Send me a picture of it, or can you verbalize it?
I could send you the link to it, like last time.
Can you paste it in the chat window of GoToMeeting?
Yes.
Yeah, there you
I
go.
just. I also changed around my desk, so I'm trying to find where to place my papers and all that. So now I'm like just using a binder to write on.
Okay. All right. Well, let's first of all see if we can factor it. In other words, before we try to find the vertex, x-intercepts, and y-intercepts, let's do the easy thing. Because if we can factor it, it'll make the others easier.
Got it.
Can you factor that?
Yes.
Into what?
You can factor it. I don't know the fact. So
Well, we start out by splitting up the x's. And then both terms have to be what? Both signs have to be what?
negative.
Correct. So it's negative, negative. And now we don't have a lot of choices. It's 3 and 1, right?
Yeah.
Where's the 3 gotta go?
3 gotta go on the right.
Which means that would have to be 1. Now, tell me if that produces the correct middle term.
1 second. So negative 1 and 6x positive, and that, oh, negative
Oh,
6x, and that gives you negative 5x.
no, it doesn't. It gives you negative 7x.
Oh, because they add to, I forgot that.
Okay, so that's not the answer. That's why you always do that check. Well, there's only one other choice, and that's if I put the 3 on the left and the 1 on the right. Now, what does that give you for a middle term?
That gives you negative 5x.
Correct. Negative 3x, negative 2x adds to negative 5x. That's the correct way to do it. So we are able to factor it. Those are the two factors. And that actually gives us the x-intercepts. In other words, we know that the x-intercepts occur when y equals 0, correct?
Yes.
So all I've done here is set y equal to 0. That's what the 0 is on the other side. That's what y was. Well, I know that when y is equal to 0, my x-intercepts, the y coordinate is 0. So I set y equal to 0. I solve this. What do I get for the x-intercepts?
We get positive 3 for the, oh, we get 3 over 2
Good.
for the right one. And then we get positive 1.
Okay. So those are my intercepts. 3 over 2. That's 1.5. That's right there. And the other one is positive 1. That's right there. Man, this is a very, very skinny parabola. How about the y-intercept? The y-intercept's always really easy because all you do is set x equal to 0. What do you get?
Oh, I've completely forgot how to do that.
The y-intercept is always that number right there.
Yeah.
It's always the constant term. Because notice, when you set x equal to 0, that term disappears, that term disappears. But the number doesn't. It always stays there. So we have a y-intercept right there. Now, that actually allows me to do a pretty good job of graphing this thing. If I try to graph it, I know it's got to do that. I know the vertex has to be halfway in between my y-intercepts. Where's the vertex at? What's the x-coordinate of the vertex?
The x. Uh, I forgot how to find.
It's halfway in between my two x-intercepts.
Oh, yeah.
So add the two x-intercepts, divide by 2, and that's your x. That's your axis of symmetry.
Yeah.
So add those two numbers together.
Um,
You get 5 halves. Divided by 2, you get 5 fourths.
uh,
So 5
5
fourths
fourths.
is this x value right there. Now, notice that we've answered most everything. We've answered that part. We've answered that part. We've answered that part. The only thing we don't have is the complete vertex, but we got the x coordinate of the vertex. So how do I get the y coordinate of the vertex?
By dividing.
Well, plug
Oh,
the x coordinate in to that function right there. And whatever you get, that'll be the y coordinate of the vertex. In other words, this right here is the equation of this parabola. So if I know the x value, I also know that it's equal to y. So if I plug in 5 fourths, I get 2 times 5 fourths minus 3 times 5 fourths minus 1. Well, what does that give me? 5 fourths minus 3 is minus 7 fourths. So that gives you minus 7 halves times 1 fourth minus 7 eighths is the y coordinate of the vertex. Now we've answered everything. In other words, the coordinate on this vertex is 5 fourths, comma, minus 7 eighths. In other words, to get the y coordinate on the vertex, is all you have to do is plug in the x coordinate into the function.
mm,
This is the function right here. So when we figured out what the x coordinate of the vertex is, figuring out what the y coordinate is really easy. Just plug it in. Now, I didn't plug it into that. I plugged it into the factored version of that because the math's a little easier. In other words, I didn't want to have to square any fractions. So I plugged it into this, which is the same function, it's just factored.
all right.
Let's go on. When it says use the zero product rule, what it means is if I tell you a times b equals 0, then you can tell me that with absolute certainty, either a or b equals 0. You cannot multiply two numbers together and get 0 unless one of them is 0. So that's the zero product rule. That tells you a has to equal 0 or b has to equal 0, and frequently either one can be equal to 0. Okay? Now, if I tell you that a times b times c equals 0, same principle. One of those three has to be 0. If I tell you a times b times c times d times e times f times g is equal to 0, one of those letters has to be 0. That's what the zero product property means.
Hmm.
So when you're looking for the roots, you're going to set that equal to 0. Because if right now this is the sum or difference of three different terms, it's 3x squared minus 7x plus 4 equal to 0. Well, I can't solve that. I have no idea how to solve that. But if I can turn it into one thing times another thing equals 0, now I'm making a lot of progress. So that's why factoring is so important. is you always want to factor these. So first of all, I'm going to set it equal to 0, and now factor it.
All right. So factors of 4, we have 2, 2, and then
Always
4.
go left to right. Don't start on the right.
Yeah. So we have to do,
You got to split up the x squared. Always. That's
yep,
step 1.
3x in the left and x on the right.
Second step, figure out both signs. Not just one of them, both. Don't figure out anything else. Just figure out both signs.
A negative, negatives both.
Correct. Now we're to the third step. And because this is a 3x and this is an x, we got to kind of throw all of our rules out the window. We can no longer say factors of 4 that add to 7. It doesn't work like that when you get to these harder ones. Okay, it works like that when you're dealing with where it's just x and x. Then you can use those rules. But we can't here. So let's consider all factors of 4. There's one set of factors. What's the other ones?
The other one is 2, 2.
And that's it. Now, what I tell most of my students, this is a trial and error process. And the very first one you want to try are the two factors that are closest together. So just for the heck of it, we're going to try 2 and 2. And then we're going to see if that produces a middle term of minus 7x. If it does, that's the right answer. If it doesn't, it's not right. What does that produce as a middle term?
Negative 7x.
Nope. What's the inside?
The inside is negative 2x.
It's the outside.
Negative 6x.
Add them together.
Negative 7x.
2 and 6 is
Oh, 8. Negative 8x.
so that's not right. So
Oh.
there's only one other possibility. And that is 3x. We know that it's got to be this. We tried 2 and 2. Well, let's try 4 and 1.
Yep.
Now, what inside term does that produce?
Negative 4x. And the outside would be negative 3. Yeah, it would be negative 3x.
Add them together.
4. Negative 7x.
That's what we're looking for. There's our answer. That's what we're looking at is negative 7x. In other words, you always got to be able to produce that middle term. Okay? That's the way you solve these. Is you, by trial and error, you try combinations until you produce that middle term. It's as simple as that. So, if that equals 0, it says find the roots. Go ahead and give me the roots.
So the left gives you positive 4x. No, positive 4.
4/3.
Over 3. Yeah.
It's 4/3.
And then,
in other words, here's
yeah.
what you're doing. Let's just be clear. 3x minus 4 is equal to 0. That's what I'm solving. Which makes 3x equal to 4, which makes x equal to 4/3. So that's how I got there. Now, do the same thing with that. Set that equal to 0, solve it.
So, wait, what are, yeah, so for,
Zero product property. Very important that you know that that's what you're doing on all three of these problems. And what that product says is that I've got two things here multiplied together. They're equal to 0. Well, at least one of them has to be equal to 0. But I don't know which one, so I set both of them equal to 0. So x equal 1, x equal 4/3 are my two solutions. In other words, is all I do is set that one equal to 0, solve it, set that one equal to 0, solve it. And there's your solutions.
Oh, okay.
Okay. Number B. What's missing from this quadratic?
The C.
Yeah, the number. It's got an x squared term, but it doesn't have a number. And guess what? That makes it a lot easier. How can you factor this? Always start with your factoring with order of priority. The very first thing you're always going to look for is a greatest common factor. Is there a greatest common factor here?
Yeah.
What is it?
It's 3.
No. X.
Oh, okay. I keep forgetting.
Well, here's what greatest common factor means. It means what's the greatest thing that will divide into each of these terms evenly. And it's only x. Notice that 3 does not divide into the first term. It divides into the second term, but we're looking for the greatest thing that will divide into both terms evenly. That's x. X goes into x squared, x times. X goes into 6x, 6 times. So this is what I have right here. Now use the zero product property to solve that. What are my two solutions for x?
0. No,
Yeah, that
1,
can be 0,
0.
or that can be 0. What's the
So the second one is positive. No, -6.
correct? There's your two solutions. And if you plug those back in and see if they work, they both do. In other words, if I plug in x 0, that whole thing is 0. And if I plug in x of -6, that whole thing is 0. And it's always a good idea to check, although you haven't really started dealing with functions yet that tend to give you extraneous solutions. In other words, remember what the zero product property says. It merely says one of these things has to be 0. Nobody said that both of them had to be 0. So when you start dealing with radicals and logarithms and absolute values, you're going to find a lot of these things produce two solutions, but one of them doesn't work. When you plug it in, it doesn't work. So you cross it off. In other words, the only thing the zero product property says is that one of these has to be 0. Okay. How about C? If I say that's equal to 0, they've done all the hard work for us. They factored it.
We just need to get the roots.
Well, what are they?
We have the left one is -5.
Good.
And then the right one is -2/3.
No, let's solve it. Rather than guessing, let's solve it by turning it into an equation. Like that. You see what I'm doing?
Yeah.
Now solve that. One step at a time.
Do we factor?
Nope. It's not factorable. There's no greatest common factor. That's a simple linear equation. So all you got to do is get your x on one side, all your numbers on another. So the first step is to subtract 3 from both sides, giving you that. And the second step is to divide both sides by -2. Well, that gives you this. So that's one solution. There's your other solution. And this was pretty easy because they didn't make us factor it. They gave it to us in factored form. So all we had to do was set that equal to 0 and solve it, which gives us that solution. And then set that equal to 0 and solve it, which gives us this solution. And again, both solutions work. They always work when you're dealing with polynomials. The only place that you have problems is when you start dealing with absolute values or radical signs. You know what I mean by those? Square
Yeah.
roots. Then you're liable to find problems that where one of the solutions does not work. And you have to be careful about it. And logarithms. You probably have not had logs yet. But when you're solving log equations, be very careful. Most of the time, one of your two solutions does not work. So always be careful about your solutions on these things, about testing.
Got it.
Okay, about number 3A. Tell me what I'm going to do.
So solve the equation below for x, check your solutions.
No.
Uh,
When I say tell me what I'm going to do, I mean give me line by line. What I'm going to do.
oh,
Okay.
all right.
I don't want a
So,
description. I want you to do it.
so we have to find. I'm trying to get this in my head. So we have to find the x's.
The first thing you
So
want to notice is as though we got two things multiplied together equal to 0.
got it.
So how do I deal with that? I'm going to use the zero product property. What does that tell me?
It tells you. I don't know, honestly.
It means set each one equal to 0. It means one of them has to be 0. Like I said, you can search for 100 years and you will not find two numbers that multiply together to give you 0. They don't exist. If you have two things multiplied together that equal 0, one of them has to be 0. So the way I'm going to solve this is I'm going to set both of them equal to 0 and solve them. They become simple linear equations. I'm going to set that one equal to 0 and I'm going to set that one equal to 0. Now solve the first one.
The first one, we're going to add 18 to both sides. And then we're going to subtract 6 from both sides.
What is 6 doing right now? What is it doing? It's multiplying, is it not?
Yes.
It's multiplying x. So you always do the opposite. What's the opposite of multiplication?
Divide. So we have to divide 6.
Divide both sides by 6. That gives you 3. Now solve the other one.
The other one is subtract 2 from both sides.
Because right now 2 is being added, so you want to do the opposite.
Then divide 3.
Divide both sides by 3.
Yeah.
So those are your two solutions. And if we plug those in, that will be a true equation with either one. Notice that if we plug in 3, that becomes 0. Well, 0 times anything is 0. And if we plug in minus 2/3, that becomes 0. Again, 0 times anything is 0. So both of those solutions are not only valid, but they're both what we want all solutions. It says check your solutions. What it means there is plug them in and see if they work. All right. So B is a little harder. They haven't factored it yet. So the first step is what?
First step is to place the x's, put one on the left and put another x in the right parentheses.
Second step?
Then we have to determine the sign, and they are both
You have
subtraction.
to determine both signs, not the sign.
Both.
There's two signs we're involved in here. And they're both negative. You're correct. Now what? Now notice that because these coefficients of the x terms are both 1, then you can apply the rules. What do we need? We need factors of 10 that do what?
That equal to 7.
Not
And
equal. That's the wrong terminology. They don't equal 7. They add to 7. Well, here's my factors of 10. Which ones add to 7?
which one? It is 5 and 2.
Right. And it's not going to matter whether I put the 5 there and the 2 there or vice versa. I'm going to get the same thing. Okay, and there's almost, I'm not quite done. Keep going. Tell me what my solutions are.
Your solutions are positive 5 and positive 2.
You got it. About number C. What's the first thing I can do with C to make it a little simpler? Well, first of all, excuse me, let me back up. What's the first thing you always try to do as a first step? It's a factoring problem. When you run into a quadratic, you can count on it being a factoring problem, okay?
Yeah.
But how are you going to factor this? What's the first thing you want to factor?
The first thing you want to factor is do the parentheses.
How about a 2?
Oh.
Notice I can take out a 2.
So we can divide
everything by 2, and you're going to see what an advantage of that is. So first of all, I've done that. Now I can divide both sides by 2. Well, 0 divided by 2 is 0. So now I've got this. Now I have a much simpler problem. The reason it's simpler is because the x squared term only has a 1 in front of it, not a 2. So factoring out the greatest common factor is extremely helpful here. Now factor it. Now it's an elementary factoring problem.
So we have to split the x squared, put one on the right, put one on the left. And then it's going to be addition, both the signs.
Now hold on. If I made both signs positive, that would be positive. Remember that number always comes from the L of FOIL. In other words, multiplying the last terms together. So there's no way they could both be positive. There's no way they could both be negative. They have to be opposite. One has to be positive, one has to be negative. That's the only way you can produce a minus 6. Remember what you're doing. You're doing FOIL in reverse. That's what you're doing. FOIL in reverse. Well, the last step of FOIL is multiplying those two numbers together. So if I'm looking at a minus 6, I know the signs have to be opposite. Now, the next step is factors of 6 that do what?
That equal to 1.
Not equal.
Or 0.
It's never equal. It's add or subtract. What is it?
Add to 1.
No, it's not even that. It's subtract because of that negative sign right there. Okay, here's factors of 6. Which set subtract to the number 1?
3 and 2.
Okay. Where's the 3 go? Where's the 2 go?
3 goes on the left, 2 goes on the right.
Perfect. Now, I don't really need to check it, but if I were to check it, I would find that that's plus 3x, that's minus 2x. They add together to plus 1x, which is my middle term. So I definitely have done it correct. So what are my solutions?
Your solutions are -3 and +2.
Good. Very good. All right, let's do this last one. 4x squared minus 1. What am I to do with that? There's actually two ways to solve this. I'll go through both of them. Help me with one of them. Whichever
All
way
right.
you want to do it is fine. There's two ways to do it.
So
Notice that this is just like a quadratic, only in no x term. It's got the x squared term, and it's got the constant, but there's no x term.
are we doing like the subtract, like add one,
We
and
can
it
do
goes to the
that.
other
Let's
side?
do that. That actually works. Now what?
Now we divide 4 on both sides.
Now what?
Then I don't know what to do from here.
Square root of both sides. When you take the square root of x squared, you get x. When you take the square root of 1/4, you get plus or minus 1/2. Notice that 1/2 times 1/2 equals 1/4. Negative 1/2 times negative 1/2 equals 1/4. So both of those are the correct answers. However, I would say that about 90% of students forget this plus or minus sign, and you will lose points. The teacher will knock off at least 1 point if you don't put plus or minus there. So let's consider the second way we can do this problem. That is the difference of perfect squares. In other words, it factors in to 2x minus 1 times 2x plus 1. That's what difference of perfect squares means. Okay? And if I solve each of these, I automatically get the correct answer. I don't have to remember to put that plus or minus sign in there. So if you do it this way, you're always going to get it correct. If you do it this way, you'll get it correct only if you remember to put that plus or minus in there whenever you take the square root of both sides. So I would almost recommend doing it that way. But more importantly, I would say 100% rule. Whenever you solve an equation by taking the square root of both sides, always, 100% of the time, begin your answer with the words plus or minus. That way you will never forget that plus or minus. And then you can do it the easy way. In other words, let me give you one. X squared equals 25. Solve that for me.
X squared equals 25. Don't we like fact?
Take the square root of both sides. We don't need to factor. You can just take the square root of both sides.
I don't know how to do square root.
All right? That's what I'm doing. Square root of x squared is x. Square root of 25 is plus or minus 5.
Oh, so it's like factors of 25, but one of them?
Not really. Not really. Let me just emphasize this point. Answer that.
Answer that. It is 2.
It's plus or minus 2.
Plus or minus 2.
Remember that when you solve an equation, there's our equation. If we're going to solve it by taking the square root of both sides, always begin your answer with the words plus or minus. If I have this, what's the answer?
10.
No. What I say always begin your words with?
Oh, plus or minus.
Now, I'm going to keep emphasizing that because I know your teacher will take points off if you don't put it in there.
All right.
Okay, so it's not trivial. You got to put that plus and minus in there when it's required. Before we go on, I forgot where we were leaving off last time. I always want to spend a few minutes with you going over these just to see your progression. So what I'd like you to do is to verbally give me your answer as quickly as possible. I'll type it in. We'll go on to the next one.
10.
Nope.
7, 8, 9. 9.
Okay. Let me tell you how to not do this. Do not do 7, 8, 9. The way I want you to do these is I want you to memorize that 2 and 7 add to 9. That's what I want. I definitely do not want you to use your fingers. That is the worst technique anybody ever came up with for doing math. Because if I said, what's 7 and 8, you're going to have a really hard time doing it if you got to count it on your fingers. So the only way to learn these is to memorize. By memorizing it, I mean you know that 2 and 7 are 9. You don't count 7, 8, 9. You don't go to a number line. Just memorize that 2 and 7 are 9.
All right. Negative 17.
Very good.
Negative 3. Oh, wait, no, negative 9.
Again,
Oh,
positive 9.
positive.
In
Oh,
other words, here's a situation where I'm going to turn a subtraction problem into an addition problem. Well, here's the subtraction sign. So that's the thing I'm changing. And because I changed that, I got to change that also. Can't change this without changing everything that's in the parentheses also. And now it's
why?
real simple. It's 3 plus 6.
Yeah. But, like, why do we change the middle?
It's just an easier way to do subtraction. In other words, what I've found that if I ask people this, confuses the hell out of them. But the reason it's confusing is because this is a negative sign right here. This is the subtraction sign right there. If I change it to an addition sign and then change the sign on what I was subtracting, I turn the problem into this. Nobody has trouble with this. What is that? What's minus 3 plus minus 5?
It is negative 8.
Yeah, and notice how much easier it is if I am adding two negative numbers rather than the original problem that I started with, which was minus 3 minus 5. These are the same thing, this and this. This one?
Not negative 3.
No?
4.
Nah, don't outthink this one. What's 11 minus 8?
11 minus.
A bigger number minus a smaller number is always a positive number. First,
Oh, it's negative 3.
a bigger number minus a smaller number is always a positive number.
Oh. Yeah, it's 3.
In other words, This is an easy problem. You don't need to change this into an addition problem. I could if I wanted to. It's just you don't need to. We know how to subtract a bigger number minus a smaller number. Everybody knows how to do that. Could I do it the other way? Well, I could change that to an addition sign, and then I would have to change that. So the problem becomes 11 plus a negative 8, and that's also plus 3, but we've made it actually harder by changing it into an addition problem. It was simple enough as a subtraction problem. We don't have any problems doing that. You don't even have any problems doing this. If you take a bigger number from a smaller number, the answer always has to be negative. So when we have subtraction problems where both numbers are positive numbers, that's a positive number, that's a positive number, that's a positive number, that's a positive number, you don't need that shortcut of turning them in to addition problems. It's when you have a negative number minus another negative number or even a positive number, that's what throws people. And that's when it's very helpful to turn it into a positive. Okay, what's this one?
-7.
No, turn it into an addition.
Oh, -9.
In other words, because you're looking at two negative signs, turn it into a subtraction problem or an addition problem.
So it's 9.
-9.
Negative.
In other words,
Okay.
it's -8 plus a -1.
Got 5.
Yeah, the only thing I really don't want you to do here is use your fingers, ever. Because what I want you to do is memorize these. I don't want you to do it manually with a pencil and paper or your fingers. You'll never memorize it if you use your fingers. In other words, if you go 4 and then add 1 to it, you get 5. That's using your fingers. What I want you to memorize is that 4 plus 1 is 5.
0.
Yeah, not really, but I know that's what they want.
Oh,
Ah,
1.
they didn't want 0. Wow. So that's undefined. That's undetermined, but I don't know how you answer that. Let's see what they give us for an answer. They're not going to do it.
SOS. That's a 5.
No.
That's weird. No, like what
Oh,
they gave us
it was
for
5. Yeah, you're right. That is very weird. Because it's not. It's not 5.
What,
0
what happened here?
Well, 0 over 0 is one of those strange things that is actually indeterminate. It's not equal to 0. It could be equal to most anything from 0 to a positive number to infinity. But it's not necessarily 0, and it's definitely not 5. But what's 4 times 1? We'll ignore 0 over 0.
4.
Okay?
It's -12.
Good.
16.
Good.
0.
Good.
-1,000. 100.
When you divide a number by the same number, what do you get? If I divide 5
Oh,
by 5, what do I
1.
get? Okay?
1.
Now if I add a negative sign to one of them, it's -1. In other words, the first thing I want you to answer here is what the sign is. I've got a positive number being divided by a negative number. The sign has to be negative. 10 divided by 10 is 1. Okay? Same thing here. I want you to give me the sign first, the number second.
Positive.
Good? 72. I don't even care if you know how to do this one or not. That's not what I'm looking for. What I'm looking for is proficiency in single digit by single digit. I couldn't care less if you can multiply single digit by 2 digits. That's not a required math skill. 1 digit by 1 digit is.
Yeah. -8.
First of all, give me the sign. Negative times negative means what?
Positive, so +8.
Sign first.
Positive. Positive.
Correct? So I don't have to put in the positive. If it's a positive, I can just put in the number. What's 28 divided by 4?
20 divided by 4 is 6.
7. Now,
7.
how do you know? Well, what's 7 times 4?
28.
That's how you know. If 6 was the answer, then 6 times 4 is not 28. 6 times 4 is only 24. So 6 can't be the answer. In other words, whatever my answer is, you have to be able to multiply it times 4 to get 28. This one?
Um,
Turn it into
14. Negative.
No, turn
Negative
it into
14.
an addition problem.
Oh.
Real simple. First of all, you got to identify what is the subtraction sign. There's only one subtraction sign. Which dash is the subtraction sign?
The middle.
Correct. So if we're going to turn it into an addition problem, I'm going to change that. And then I got to change whatever's the sign in the parentheses. I got to change that. So now the problem becomes -3 plus 11. What's that?
-3 plus 11 equals 8.
Correct. See how much easier they become when you turn them into addition problems instead of subtraction. Go ahead, sign first. Whenever you're doing multiplication or division, I want you to give me the sign first. Then give me the number. Figure out the sign immediately.
Positive? No, negative.
A negative times a positive, if I am multiplying a negative times a positive, it's negative. If I am dividing a negative by a positive, it's negative.
So it's -70. -55. 0. 8.
So all you got to do is spend some time practicing these and you will be perfect at it. I guarantee it. But it's going to take a little effort. It's not going to get into your brain by osmosis. And this is the easiest way I've ever seen to practice this. I'm not kidding you that if you just spent 10 minutes a night on this, it would make a world of difference in your math skills. It really would. Because you really can't go beyond this. If you can't do these, you can't go beyond it. It's just almost impossible. You can try using a calculator, but that even is almost impossible. It just is. Trust me. You've got to get proficient at doing single digit by single digit operations.
Got it.
Sign on this?
Negative.
Number?
8.
Sign?
Negative. No. Yeah,
No.
negative.
Whenever you are doing multiplication or division, if the signs are opposite, then it's always negative. In this case, the numerator is negative, the denominator is positive. That's got to be a negative answer. Or if I was multiplying -33 times +11, the answer would have to be negative. So that's all you have to check for to get the sign. If you got 2 negatives, it's a positive. If you got 2 positives, it's a positive. But if one is negative and one is positive and you're doing either multiplication or division, the answer is negative. And
-3.
Right.
9. -5. -2.
Turn it into a subtraction. Turn this subtraction problem into an addition problem.
Negative. Oh, -14.
Perfect.
Negative. Oh, yeah, just 10. Uh, 14.
Sign first.
Negative? No, positive.
Okay. Number next.
11. It is positive 15.
Turn it into an addition problem. What do I got to do to turn it into an addition problem? Where's the subtraction sign?
In the middle.
Okay, so how do I turn it into an addition problem?
You change the middle one into a positive and the 9 into a positive.
Now, here's the problem. Whenever you have two positives together, you can just assume that one of them is positive. In other words, you can always drop one of those positive signs. What's that?
That is -2.
Which one is bigger?
Oh, it's positive 2.
When you're adding two numbers, whichever is the positive number, if that's bigger, your answer is positive. If the bigger number is the negative, your answer is negative.
-5. 9.
Sign first.
It's negative.
Turn it
Negative.
into two problems. I want two problems. I want sign first whenever you're doing multiplication or division, and then the number.
So it is negative and
Now, if your memory
18.
fails you here, and you don't remember what 6 times 3 is, then it's okay to go 6, 12, 18 to figure out what it is. In other words, I'm not asking you to use your fingers, but just add 6 to itself twice. 6 plus 6 is 12. 12 plus 6 is 18. So 3 times 6 must be 18. Okay? Now,
Yeah.
at some point, you're gonna memorize it. You're gonna know. You could be in the middle of sleeping, and if somebody said, "What is 6 times 3?" you're gonna know it's 18. But you're not quite there yet. So that's why I want you to do these. 11 times 11 happens to be 121. I couldn't care less if you know how to do that. Or this one. Go.
2. This is -7.
Good.
0.
Good.
16.
Nope.
-16.
That's why I want you to do sign first always.
So you convert. Wait, actually, this is fine as it is.
Problem. It's adding two negative numbers.
-10.
There you go. Now, the only thing standing between you and really good math skills is this. You've got to get better at this. Now, I can see you getting better in just doing it for 10 minutes. You made drastic improvement in just 10 minutes. Imagine how good you would be, because it's basically memorizing. Once you figure out how to handle the positive and negative signs, then it's just memorizing. 3 plus 7 is 10. Okay, that'll happen automatically. You won't even have to try to do that. But what you're going to have to do is put some time in on this. And I guarantee you, you will thank me for it. It will make
Mm-hmm.
the world of difference in your math. It just will. You cannot do algebra problems without knowing how to do that stuff. It's just impossible to do. There's too many algebra problems that requires you to do all these little things. Remember C, we had to divide everything by 2, and then we had to add 6. I mean, you're just, every single equation you are confronted with is a bunch of simple little calculations, all of them. So if you fall down on those calculations, you got no shot. But if you get really good at those flashcards, these are going to be a piece of cake for you. Then is all you got to do is memorize the method.
Yeah.
But in order to, the method doesn't do you any good if you don't have a strong foundation in the fundamental arithmetic part of it. So that's what I'd like to see change. And I think it's just going to take some effort. I can tell that if you spend even 10 minutes on it, and in 2 days' time, you'd be almost expert at it. All right? So I think we have sessions scheduled.
Tomorrow.
Not
Right.
tomorrow. I got you on Wednesday and Thursday. I don't have one tomorrow. You want one tomorrow?
No, I'll be good.
Okay. Josh, I'll talk to you Wednesday at 4.
All right.
All right.
See you.
Bye-bye.
Bye.